Hi, I'm Mara, and today I'm going to be presenting a comparative business analysis of two aerospace companies that on the surface operate in similar industries but could not be more different in how they think, operate, and compete. Boeing was founded in 1916, employs over 150,000 people, and generates roughly $78 billion in annual revenue. And they've also spent a century building commercial aircrafts, defense systems, and spacecraft for government and airlines across the world. It is in every sense a legacy institution. SpaceX was founded by Elon Musk in 2002 with the stated goal of making humanity multiplanetary. It has grown to a valuation exceeding $350 billion as of 2025, holds over 60% of the global commercial launch market, and now operates in the world's largest satellite internet network through Starlink. All right, taking a look today, I'll be comparing the two companies across 7 dimensions: value, discipline, market segmentation, customer loyalty, AI and big data use, digital transformation, organizational culture, and people analytics. And then I'll close with my personal takeaways. I also want to note that culture is a big overarching theme here, so just take note of that as I go through. The first topic is value discipline. Boeing has historically pursued operational excellence. Its competitive advantage was built on the ability to manufacture complex aircraft at enormous scale, navigate FAA certification processes effectively and efficiently, and deliver reliable planes on predictable timelines to airline customers who are depending on them for their entire business model. The problem is that Boeing has been failing its own discipline. The 737 MAX crashes in 2018 and 2019, which killed 346 people, were caused in part by a software system that was inadequately tested and whose risks were downplayed during the FAA certification process. A 2024 Senate subcommittee investigation found that Boeing's internal culture had been suppressing quality and safety concerns from engineers for years, prioritizing production speed and financial targets over engineering rigor. SpaceX's discipline is product leadership, and it executes it with remarkable consistency. Its core innovation, the reusable orbital class rocket booster, was widely considered impossible by competitors when SpaceX first attempted it. By early 2025, Falcon 9 had completed over 300 consecutive successful launches and captured more than 60% of the global commercial launch market. Its development philosophy, often described as test to failure and iterate, means SpaceX treats explosions as data rather than disasters. The Starship program is the clearest example. It failed catastrophically in its first 3 test flights, and SpaceX engineers openly described each explosion as a success because each failure generated the data needed to fix the next step. By the 4th test flight in June 2024, both the Super Heavy booster and the Starship upper stage completed successfully controlled returns. The next section will be on market segmentation. Boeing segments its market primarily through 2 major divisions. Boeing Commercial Airplanes, or BCA, targets airlines and aircraft leasing companies. This is classic B2B segments broken down by geography, domestic versus international carriers. By fleet size, distinguishing large legacy airlines like Delta or American from low-cost carriers like Ryanair or Southwest. They also focus on route types, since long-haul international routes will require different aircraft than short regional hops. Boeing Defense, Security, and Safety, or BDS, serves national government and military clients primarily through the Department of Defense and NASA, along with allied foreign militaries. This is a B2G, or business to government, segment defined by mission type: fighter aircraft, surveillance systems, military helicopters, and space launch vehicles. What's notable about Boeing segmentation is its relative narrowness. Every customer is either a large institution or a government. There is no consumer-facing business at all. SpaceX's segmentation is dramatically broader. It serves government launch clients through NASA crew and cargo contracts and U.S. Space Force launch contracts. It serves commercial satellite operators through its Falcon 9 launch services, accounting for that 60+% market share. It serves enterprise customers through Starlink for aviation, maritime shipping, and military communications. And crucially, it serves individual customers through Starlink home broadband, with over 4 million active users globally by late 2024. SpaceX's psychographic segmentation is also worth noting. In its institutional markets, it targets agencies and operators who are willing to accept the risks of working with a commercial provider in exchange for dramatically lower costs. Next section will be on customer loyalty. Boeing's approach to loyalty is built on what you might call an ecosystem lock-in. Its Boeing Global Services division generated over $19 billion in revenue in 2023. Airlines that fly Boeing aircrafts become deeply integrated into Boeing's service ecosystem. Switching to Airbus doesn't just mean buying new planes. It means retraining pilots, replacing tools, restructuring maintenance contracts, and rebuilding supplier relationships. These switching costs are enormous, and they create a form of loyalty that is more structural than emotional. Boeing also leverages its analytics platform to build data-driven stickiness. Analytics provides airlines with predictive maintenance analytics, fuel efficiency optimization, and operational performance insights drawn from real-time aircraft sensor data. Once an airline is plugged into the system, they're receiving Boeing-generated value every day, which also deepens the dependency. So SpaceX's loyalty model is almost the opposite. It has no formal CRM program, no loyalty tiers, no service ecosystem designed to create that lock-in. Its retention strategy is entirely performance-based. It keeps customers because it delivers. Over 300 consecutive successful Falcon 9 launches as of 2025 creates a compelling case for any satellite operator or government agency considering alternatives. SpaceX's unusual choice to live stream its launches, including failures, also builds a kind of institutional transparency that generates trust in a different way than Boeing's approach. For Starlink's customers, loyalty is cultivated through product improvement. SpaceX continuously upgrades download speeds, expands geographic coverage, and improves hardware with each generation. The next section is on AI and big data comparisons. Boeing's AI and big data use in marketing is sophisticated, but primarily operational and B2B in nature. The Boeing Analytics Suite is central here. It collects real-time data from aircraft sensors across the airline's entire fleet and uses that machine learning model to predict component failures before they happen, recommend maintenance schedules, and optimize fuel burn and route efficiency. For marketing purposes, this data becomes a value proposition. Boeing's sales team can walk into an airline negotiation to show precisely how much a Boeing fleet reduces total cost of ownership compared to the alternative. That's AI-powered persuasion at the institutional level. Boeing also deploys digital twin technology, which uses AI models to create virtual simulations of individual aircrafts. These simulations allow Boeing engineers and sales teams to project how a specific airline will perform over a 20-year life cycle, accounting for route patterns, climate conditions, and maintenance histories. It's a powerful tool for closing on those long-term contracts. SpaceX's AI use is less visible from the outside, but arguably more deeply embedded. The Starlink app, which Starlink subscribers use to manage their service, uses machine learning to continuously optimize antenna positioning and network handoff between satellites. This directly improves the user experiences and reduces the likelihood that a customer will cancel their subscription, making it a form of AI-driven churn reduction that is baked into the product itself rather than added on top of it. At the institutional level, SpaceX uses telemetry data from its constellation of thousands of satellites to model network capacity demand geographically. The capacity planning data informs which markets SpaceX prioritizes for commercial and government Starlink expansion, which in turn shapes its B2B marketing pitch for maritime operators, airlines, and defense contractors. The next section will be on digital transformation. For Boeing, the defining digital transformation event is the 737 MAX crisis. The MCAS software failures weren't just a safety failure, they were a digital engineering failure. Boeing lacked robust cross-functional data integration, simulation, validation, and software certification processes. When these gaps were exposed, Boeing was forced into a significant digital transformation program. The response was the Boeing E-Enabled Advantage initiative, which involved over $400 million in investment in model-based systems engineering, cloud-based design, build, test, integration, and digital quality management. The new CEO, Kelly Ortberg, has repeatedly framed this transformation as a cultural mandate. Boeing must become a learning organization that uses data to surface problems early rather than suppress them. For SpaceX, the defining digital transformation event is the Starship Integrated First Flight Test Program, which began in April 2023. Unlike Boeing, SpaceX did not have legacy IT infrastructure or paper-based engineering processes to transform away from. The company was built digitally from the start. All Starship design, simulation, manufacturing, workflow, and test analysis pipelines were integrated in custom digital environments. When the first Starship test ended in an explosion approximately 4 minutes after launch, SpaceX engineers didn't describe it as a failure. They described it as a data collection event. Thousands of sensors embedded throughout the vehicle had generated terabytes of telemetry during those 4 minutes, and that data fed directly into AI-assisted failure analysis and structural redesign. Within months, the second vehicle was already ready. By the fourth test flight in June 2024, both stages completed their mission objectives successfully. In terms of culture and digital maturity, Boeing's culture has been extensively analyzed in the wake of its quality failures, and the picture that emerges is troubling. Multiple congressional testimonies and independent investigations from 2022 to 2024 describe an organization where engineers and quality inspectors hesitate to raise concerns because those concerns are likely going to be filtered out or penalized by middle management layers focusing on hitting production targets. This misalignment has concrete consequences. Boeing can deploy a real-time quality dashboard in a factory, but if the culture discourages workers from flagging anomalies because it slows production, the dashboard is effectively decorative. The technology exists, the willingness to act on it shows that it does not. Boeing has taken meaningful steps to address this. The AWS and Microsoft Azure programs have modernized its cloud infrastructure, and hopefully it'll start to change in the near future. SpaceX's culture is what organizational theorists might call a digitally native culture, one that was built in the digital age and has never had to transform away from pre-digital habits. The organization is structured around radical transparency. Engineering data, launch results, test failures, and mission outcomes are visible to everybody in the company. There is no culture of information hoarding or hierarchical filtering. When something goes wrong, the data says so immediately and unambiguously where everyone can see it. This transparency is enforced by organizational flatness. SpaceX's leadership layers are thin and cross-functional communication happens through direct access to shared data systems rather than through management chains. The risk of this culture are real and worth acknowledging. Industry estimates suggest that SpaceX's annual attrition rate runs between 15 and 20%, far higher than Boeing's. SpaceX's culture may be excellent at accelerating product development and retaining its highest performers, but it comes at a high, significant human cost. Looking at analytics for personnel decisions, Boeing uses institutionalized HR analytics platforms, primarily Workday for core HR functions and SAP SuccessFactors for performance management, succession planning, and learning and development. During the 2024 restructuring, Boeing used workforce analytics to identify roles with significant overlap or redundancy, assessing where gaps in digital engineering competency existed relative to its transformational goals, and prioritizing retraining investments for employees transitioning into new technical roles. Promotions at Boeing are governed by structural competencies frameworks. Employees advance through levels tied to engineering certifications, safety training completions, and performance review ratings and leadership assessments conducted by managers. This approach is more systematic than many companies of comparable size, but at the senior level, promotions remain largely human adjudicated based on relationship, visibility, and institution reputation as much as a measurable performance data. SpaceX's approach to people analytics is harder to document from the outside because the company shares relatively little about its internal HR infrastructure. SpaceX's hiring process is designed to filter for a specific kind of thinker, not just a specific skill set. Once hired, promotions at SpaceX are driven by mission contribution rather than tenure or formal credentials. The engineers and program managers who have advanced quickly are the ones visibly solving hard problems. The analytics system at SpaceX isn't a software platform, it's the work environment itself. High performers surface naturally because the results of their work are visible to everybody. In terms of key learnings and takeaways, these are my two personal takeaways from this analysis. One practice I'll carry forward and one I'll hope to avoid. From SpaceX, the lesson I want to apply is treating failure as structured data rather than as a reputational or personal setback. SpaceX's engineering culture reframes the question after a failure from what went wrong and who's responsible to what did this reveal and what do we change next. This is a fundamentally different posture, and it produces faster learning. I want to build that into how I approach academic projects, group work, and eventually professional work. After any significant setback, I want to do a brief, honest debrief. What happened? What were the root causes? And what specifically changes next time? Write it down and then execute that change. That's how SpaceX does it, and that honestly seems very helpful. From Boeing, the practice I want to avoid is letting short-term metrics or social pressure suppress honest risk assessment. Boeing's most costly failures weren't caused by lack of data. The engineers knew that something was wrong. These failures were caused by a culture where raising those concerns felt career-limiting or disruptive, so people stayed quiet. The lesson is about psychological courage. Build the habit of asking, what might we be ignoring because this is inconvenient to say out loud, especially when performance metrics look strong. Problems that are suppressed during apparent success become catastrophic when those conditions change, and I want to be the person that names those risks early, not someone that waits until it's too late. If you take a look here, these are the key sources that I used. If you have any questions, I'd be glad to answer them.